Chapter 11 exam review starts at number 38. Again, you have these equations in front of you for your exam, so make sure you use them, but I will write them at the top of the question. So the area, remember area is pi r squared for a circle, and the circumference is 2 pi r, or pi times the diameter. Either one works for circumference. And when we read this question, it says to leave it in terms of pi. So remember, we're not putting pi into our calculator, and we'll just calculate everything else and include units. So when I look at this, first thing I'm going to do is, I know the radius is 9 and 9. So I'll go ahead and find the area first. So area is equal to pi times 9 squared. So the area is equal to 9 squared is 81 pi. And the unit is inches. So it's squared because we are in area. Circumference is equal to 2 pi r, or pi d. You're going to get the same answer. So the circumference is 2 pi times 9. And 2 times 9 is 18 pi, or the diameter is 18, so you also get 18 pi. And it's just measuring the distance around the circle, so that is inches. Find the area of a sector with the central angle of 130 degrees and the radius of 32. Okay, so if you need to draw a picture, you can, but when we do arc length, or area of a sector, we're going to do the area of a sector equation, and again, that's on your equation sheet. So area of a sector is equal to the measure of the arc, we call it AB in our equation, over 360 degrees times pi r squared. Okay, again, we're dealing with area, so that is what we're looking for. And so I'm just going to go ahead and plug in what I know and solve. So I know the angle is 130. I put that over 360. Pi times 32 squared all over 1. And I like to simplify the numerator first and then the denominator straight across. And so I go ahead and do 32 squared times 130. And we get a pretty big number. We get 133,120 pi all over 360. And so we can go ahead and plug this in our calculator. So I'm going to take that times pi and then divide it by 360. And I get 1,161 point, and it doesn't tell us how to round. We'll just practice to the 10th place, so 1 decimal would be 0.7, and then my unit is inches squared, because again, we're finding the area of that sector piece. Number 40, find the arc length of LM. So again, arc length is very similar. You have the equation in front of you, but it's the measure of the arc AB out of 360 degrees times 2 pi r. So again, I'm just plugging in what I know. I know r is 5 and the arc is 50 degrees. So 50 over 360 times 2 pi times 5. And again, I put it over 1. I like to simplify the numerator and then the denominator, and then go ahead and go from there. So 50 times 2 times 10, or 2 times 5, is 500. So we have 500 pi on the top, all over 360 degrees. And so, again, I just plug this into my calculator. This one does tell us to round to the nearest 10th, and I get that the arc length is 4.4. And again, looking at the unit feet, so the distance from L to M is 4.4 feet. 41, so these are rhombuses and kites. They use the same area equation, which the area is equal to 1/2 diagonal 1 times diagonal 2. So pretty straightforward if you understand what that means. Diagonal 1 is a total distance of 12. Diagonal 2 has a distance of 20. And so we are honestly just plugging in 1/2 12 times 20 and getting that answer. And I get 120 units squared. There's no unit on it, so we can just call it units squared, right? Making sure we still include that. Example B, same thing applies. The first diagonal is 14. My second diagonal has a distance of 18. And so area is 1/2 14 times 18. And again, no units are included, so I get 126 units squared. All right, the last two problems are probably the hardest of chapter 11, and that's finding the area of regular polygons. And so we know that our equation is area equals 1/2 the apothem times the perimeter. And we have to be able to solve those. It normally takes a little bit of like SOHCAHTOA to be able to do that. So I'm going to walk you through these, and then hopefully you have a clearer idea of what's happening. So I go ahead and draw my center of the polygon, and I create my radius to each vertex. We start by doing 360 degrees divided by the number of sides, and so we get 120 degrees, and that is this whole entire angle. But we need to cut it in half because that creates my apothem. Remember, the apothem is from the center to half of a side. And so I'm going to go ahead and divide that by 2, and I get that the inside angle right here is 60 degrees. Now, I don't like to work in that small of a space, so I'm going to redraw my triangle so that we can see what's happening a little bit better. So I have 60 degrees in this top angle. My apothem is this straight down side. And then it says that my apothem is 5, so I'm actually going to label this 5. And so I'm going to go ahead and put that in my equation too, so I know that I have that piece taken care of. And now I'm looking for the perimeter, and in order to find the perimeter, x, I need to be able to find x and then apply it to know every single side in this shape. So looking at what we have opposite and adjacent, so I'm going to use tangent. So tangent of 60 is equal to x over 5, and I'm going to multiply both sides by 5. So x is equal to, let's see, and we can round it to the hundredths, so 5 times tangent of 60. Make sure I'm in degrees. I got to change that. Degrees. Okay. So I get that x is 8.66. So this part of the line is 8.66, but I want to know the whole entire side, so I have to multiply that by 2. So 8.66 times 2 is 17.32, and there are 3 total sides to the triangle, so I'm going to take that number times 3. And I get that the perimeter is 51.96. And so now I have everything I need for my equation, and I can plug in 1/2 of 5 times 51.96. So 0.5 times 5 times 51.96. And I get 129.9 centimeters squared. All right, let's try it again. Now we have a hexagon, and the hexagon has 6 sides. So I'm going to go ahead and draw in a center with a couple radii, and the side length is 12. And so then I'm going to get started. So we do 360 divided by 6, which is 60. And then I'm going to divide it by 2 because I want to cut this in half because I need to find the apothem. So this angle right here is 30. And again, I like to draw my triangle again so I can see a little bit bigger what I'm dealing with. 30 degrees. Half of the side, if the whole thing's 12, this bottom part is 6. And then I have the apothem on this side right here. So I'm doing the same thing. I have opposite and adjacent. And so I'm going to go ahead and use tangent. So tangent of 30 is equal to 6 over A. And I need to multiply both sides by A. So A times tangent of 30 is equal to 6. And then we divide both sides by tangent of 30. And I get that my apothem, 6 divided by tangent of 30, is 10.39. So I know my apothem. I can figure out my perimeter pretty easily. The perimeter is 12 times 6 sides, right? So 12 is the side length times 6 sides. So that's the perimeter, 72. And then we can go ahead and just plug this into our equation. So area is 1/2 of 10.39 times the perimeter, which is 72. 10.39 times 72. And when I put that in my calculator, I get that the area is 374.04 centimeters again squared, because we're finding